Propagation of errors. Introduction. When we perform experiments in physics, we often use many measured values to find a final result. Each measurement has its own error, and these errors combine or propagate based on the type of mathematical operation we do. Why do errors propagate? Instruments have limitations. Multiple measurements are used in calculations. Final results depends on both individual errors and the mathematical operations we do. Types of error propagation. 1. Addition. If Z equals A plus B, then the final error del Z equals del A plus del B. Maximum error in sum equals sum of absolute errors. Let measured values A equals A plus or minus del A. The A on the left hand side is the measured value of physical quantity A, whereas A on the right hand side stays it's the true value of all measured values of A. Del A gives the absolute error in the each quantity. Similarly, B equals B plus or minus del B. Then Z equals A plus B. So, Z plus or minus del Z equals, instead of A, let us write A plus or minus del A. Instead of B, let us write B plus or minus del B. Rearranging, we get A plus B separately plus or minus within bracket del A plus del B. Hence, del Z means equals del A plus del B. If you have too many quantity in addition, then we get del Z equals del A plus del B plus del C plus etc. 2. Subtraction. If Z equals A minus B, then the final error del Z equals del A plus del B. Even in subtraction, errors adds up. Let measured values of A equals A plus or minus del A. B equals B plus or minus del B. Then Z equals A minus B. Substituting, Z plus or minus del Z equals A plus or minus del A minus B plus or minus del B. Rearranging, we get A minus B together plus or minus within bracket we get del A plus del B. Here subtraction, in subtraction the absolute error never subtract each other, they only add up. Hence, del Z equals del A plus del B. Similarly, if too many quantity subtract each other, then del Z equals, it's simply addition, del A plus del B plus del C plus etc. 3. Multiplication. If Z equals A times B, then the final fractional error del Z by Z equals del A upon A plus del B upon B. Fractional errors add. Let measured values of A equals A plus or minus del A, B plus or minus del B. Then Z equals A times B. So, Z plus or minus del Z equals, instead of A, we write A plus or minus del A. Instead of B, let us write B plus or minus del B. On multiplying this quantity on the right hand side, we get, neglecting the very small values multiplication of del A and del B, we get del Z equals A times del A plus B times del B. Now divide both sides by Z, left hand side by Z, right hand side by AB. So we get the final fractional error del Z upon Z equals del A upon A plus del B upon B. Division. If Z equals A upon B, then the fractional error in Z, del Z upon Z equals del A upon A plus del B upon B. Here fractional errors add. Fractional errors add. Let measured values A equals A plus or minus del A, B equals B plus or minus del B. Then Z equals A upon B. So Z plus or minus del Z equals, on the numerator we have A plus or minus del A divided by B plus or minus del B. We use binomial approximation and we get 1 plus or minus del Z upon Z equals 1 minus or plus del B upon B plus or minus del A upon A plus or minus del A upon A multiply del B upon B. The last term del A upon A multiply del B upon B we neglect because these values are very small. So we get the final fractional error in Z, del Z upon Z equals del A upon A plus del B upon B. 5. Power. If Z equals A power n, then the fractional error del Z upon Z equals n times del A upon A. Fractional error get multiplied by power. Let measured value A equals A plus or minus del A. Then Z equals A power n. So Z plus or minus del Z equals A plus or minus del A to the power n. Z plus or minus del Z equals, let us remove A from within bracket. So we get A power n outside the bracket. Within bracket we have 1 plus or minus del A upon A to the power n. Z plus or minus del Z approximately equals A power n multiply within bracket 1 plus or minus n times del A upon A. Here we have used the binomial expansion 1 plus x power n equals 1 plus nx. So the final fractional error del Z upon Z equals n times del A upon A. 6. General formula. If Z equals A power P multiply B power Q divided by C power R, then the final fractional error del Z upon Z equals P times del A upon A plus Q times del B upon B plus R times del C upon C. Multiply fractional error of each quantity by its respective power. Multiply 100 to get percentage error. Percentage error in Z equals del Z upon Z multiply 100%. Propagation of errors. Summary table. Operation, formula, final error, type of errors. First, addition. Formula is Z equals A plus B. Final error del Z equals del A plus del B. Type of error is absolute error. 2. Subtraction. Z equals A minus B. Final error del Z equals del A plus del B. Type of error is absolute error. Operation 3. Multiplication. Formula Z equals A times B. Final error, final fractional error del Z upon Z equals del A upon A plus del B upon B. Type of error is fractional error. 4. Division. Formula Z equals A upon B. Fractional error. Del Z upon Z equals del A upon A plus del B upon B. Type of error is fractional error. 5. Par. Z equals A par n. The fractional error. Del Z upon Z equals n times del A upon A. Type of error is fractional error. 6. General expression. Z equals A power P B power Q divided by C power R. The fractional error. Del Z upon Z equals P times del A upon A plus Q times del B upon B plus R times del C upon C. Type of error is fractional error. Percentage error in Z equals del Z upon Z multiply 100%. The type of error is percentage error. Notes. Absolute error means the direct error values are added. Fractional error means errors are expressed as ratio del A upon A. For products, quotients and pars, fractional errors are always added, not subtracted. For very small errors, we neglect higher order errors terms like del A upon A multiply del B upon B. Conclusion. So remember, in physics, how we calculate matters as much as what we calculate.